So, like I said, we'll be recording the questions just so they have something on that. We'll also take some more. Then we'll go into our lesson. Our lesson should take us like 20 minutes. Shouldn't be very long, so you could finish your homework today in class. And then if we also get done with the other part, that's the other thing I want to get done, is just knowing how to go from a polar equation to a rectangular equation and a rectangular equation to a polar equation. Make sense? Those are the only things that we need to make sure we know how to do. So, any questions on the homework? Nope, nope, nope. Give me the point. Okay? Cool, give me what it is. Okay? So, let's look at where this is located first off. So notice 2.36 radians is somewhere up here, right? So this is 2.36. Now we might want to find the reference angle, which is this part right here, right? So that's pi minus 3.16. So I'm just going to go 3.14 minus that. So what is that? Little borrowing. 78.78. Okay. So that's going to help us in the long run, just to know that. And then notice we have 1, 2, but it's somewhere in here. With me? Now, obviously, our radius is always going to be this. We're just going to flip it to negatives and so forth. Okay? So one way to do it is I could go backwards. That's pi plus 0.78, right? So that's 3.14 plus 0.78, which is 3.92. So I have root 2 comma negative 3.92. With me on that? Or I could do the radius negative, correct? And then it'd be negative 0.78. Because then I'd be down negative 0.78 and then push through. Does that answer your question? Okay, they just added 2 pi. Right? Does that make sense? So they just added 2 pi to, because 2 pi is 6.28, right? So when they added that, that's what? 8.64, is that what it was? There you go. Because obviously to get back to this same spot is just add 2 pi back to it, right? With me? Okay. But the other one would work as well. Anybody else? Any of you guys have questions on how to go from rectangular to polar, polar to rectangular? The polar to rectangular is pretty simple. And then the things that I would suggest you know how to do on your test is, 1, know how to take a rectangular point and turn it into a polar point. Okay, let's try and just do one of those just so you'll know. Let's do the point -4, comma -5. Okay, so if we're going to a polar point, once again, we need our radius and we need to know our theta, right? So I'm going to graph that really quickly. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, go ahead and draw it. That's horrible, but you get the idea. So he's -5, he's -4. Good old Pythagoras tells me that's root 41. How I did that is just Pythagorean theorem, or you could say x squared plus y squared equals r squared, right? Is everybody with me on how I got root 41? Okay, and then what do we always use to find the angle? Well, I could actually use any of the trig functions, but what's always given to me if I have a rectangular point? The y and the x coordinate, right? Because we know that tangent of theta is y over x. Okay, so if I plug that in, it's basically saying I got the tangent of theta is 5/4. How are we going to go ahead and find the angle? We take the arc tangent. Somebody want to find that for me really quick? Arc tangent 5/4. What do you got, brother? Okay, let's put it in radians though. Okay, so 0.8691, so we'll go 0.87. But that's up here, huh? That's up in this quadrant 1. And that should make sense because tangent's positive in quadrant 1 and quadrant 3, right? So therefore, they're going to give me the angle in quadrant 1 because if you recall, the arctangent is either going to be in quadrant 4 or quadrant 1 because that's where the inverse tangent puts it, right? You guys remember that? But is that the location of where I'm at? No. So therefore, I got to use this as, this right here is 0.87. And then that means that we're pi plus 0.87, so 3.14 plus 0.87, which is 4.01. And that would be where it's located. Okay, so know how to go to rectangular to polar. Notice we didn't do a bell quiz. This is why I'm going to go over this a little bit, just because everybody's gone. So you guys are like the only class that half of your class is gone. Everybody else is like 5 students. So, any questions on how you went rectangular to polar? Polar to rectangular is really easy. How would I do it if I have a polar point? Let's go -2, pi thirds. So we would have to push through. So once again, radius of 2, 1, 2. Notice pi thirds is kind of like this. So if I want to push through because it's a negative, I'm down here at 4 pi thirds, right? Does that make sense to everybody? Not the best graph, but it'd be located right there. Because I have to push through because it's negative. So really, if we look at it, we're pretty close to being close to 0, down -2, but not exactly, right? Okay, so let's go ahead. And remember, the way we go from polar to rectangular is using x equals r cosine theta, y equals r sine of theta, do we already know what r and cosine is? I mean, r and the theta is. So we just go, okay, so this is -2 times the cosine of pi thirds. Cosine of pi thirds is 1/2, right? 1/2 times -2 is -1. My graph's not that great. So that comes out to be -1. -2 times the sine of pi thirds comes out to be -2 times √3/2, which comes out to be -√3. And then at that point right there, the same thing, right? I know it's not the most accurate thing that I just did, but it's there. And then the other two things you're going to do is you're going to take a polar equation and go to rectangular. Okay, polar equation into a rectangular. But I'm not going to do notes on that yet, but we'll come back to it. I want to get this stuff done first and then come back to it. That's okay. So that's the third thing you're going to need, but this is an equation. And then the fourth thing is taking a rectangular and going into a polar. Same thing, still an equation. Those are the 4 things you're going to need to do. So basically, we covered half of the things that you're responsible for last time's lesson, right? Okay, any questions so far? All right, let's actually work on today. Today is 8-1 and 8-2. We're going to do both. This is a very quick unit because it's stuff that you guys have known before. I don't know yet. So let's go ahead, guys, and if you guys are in the back, I'm going to ask you for your help as well. So anybody that's in this classroom, we're going to go ahead and it's Coach G's birthday, if anybody cares. Anyway, Gibby, shoe size. Holy hell, brother. So let's just go even. So would you want to do 10? Okay. No, we're just going to do whole numbers. 12. Faith, you're going to do it in terms of boys, though. So add, subtract 2 from your size. Littlefoot over there. What do you got, Timmy? Devin. That'd be Devin. You have a 12? Huh. That's what I have. 10. Ladies, remember to subtract 2 from this yellow shirt here. Shoe size. You don't know your shoe size? I'll come back to you. Check out your shoe. Miss Red? You'd be a 4 as well. Okay. Thank you. Classes? 7, so you are a 9. Little glasses? 7. Big guy? You wear a size 10? You're that tall and you wear a size 10? Wow. You're a tall kid to wear a size 10. Did you find out? You're a 7. Red shirt? You'd wear 11. Buddy? You do not wear size 5. You don't have to subtract 2 from your shoes. You are 7. Boys, do not take away 2. 6. Are you still a 10, Mr. Tall Guy? You subtract 2? Holy hell, I can't believe you wear a size 10. How tall are you? Stand up for me. Okay. What's up, bud? You are 12. Okay. Miss Checkers? 7. Ma'am? 4. We got some midgets in here. What? 11, thank you. 14. Miss with the headphones? So we're going to go 5. And then, okay, awesome. So really quickly, once again, we're doing mean, median, mode, okay? So I just got this. If I write it down, dude, do you think you should write it down? Come on. If you feel good, I don't. You two, you do whatever the hell you want to do. That's more. Now, this is a lot of calculator work today. So get out your calculator if you have it. Do you have a calculator today? Any of you guys in the back want to go fill up my water bottle at drinking fountain? Yeah. You just became my favorite. Thank you. Yeah, it doesn't matter. Go to that one or that one. I'm being very specific. There you go. You're like, I'm going to go all the way out to the seminary building because I heard it's got cold water. I know. Okay, so here we are. We have shoe sizes, okay? So basically everything we're going to do today is off of this one data set. Does that make sense? Everything. So we're going to go through. And I'm going to come back to it, but we're going to start with mean. What does, again, mean? Another word of that is average. And we're not going to do this by hand, guys. We're going to let the machine take care of us. So average. Okay, and what does that mean? We're going to add them all up, divide by however many there is, right? Okay, what's the next one? Median. Which means what? The middle. Now, you go lowest to highest, yes, sir. So we are going to have to arrange our data, but we're going to let the machine do it for us. Okay? So we're going to let that happen. Our calculator is going to tell us every single one of these things except for the mode. The mode you're going to have to look at yourself. So the mode, how I remember, is the one with the most. So I changed the D with a R, so more. Does that make sense? Now, there's some different ideas out there. Some people say that it can be multiple numbers for the mode. And some people say if there's more than one number that's the same amount, there's no mode because there's not something with the modes. Okay, we're going to be the people that there can be multiple. Does that make sense? So if there's multiple about the same amount of numbers, like if one's 7, like say shoe size 7 is 8 times and shoe size 11 is 8 times, we'd use shoe size 7 and 11 as the mode. Make sense? Now, what if, let's try and talk about the median again. If it is an even amount of numbers, is there a direct middle? So what do you do if there is an even amount of numbers? You go to the innermost 2 and you take the average, right? If there's an odd amount, there's a specific middle number, isn't there? Okay, is everybody with me on that? Okay, like I said here though, we're going to go ahead and let our calculator do the work. Okay, so here we go. You guys are going to help me with the numbers because I can't plug numbers in and look at my screen. So you're going to help me out. So let me show you how you do so. So you go ahead and hit Stat, Edit. Now right now, if you see, my L1 has information in it already. I can't remember how to find yours, but remember when we did, you should know how to at least put it into data. Okay, cool. All right, so I am going to go up here and clear my list by putting up on L1 and hit the clear button. Whatever you do, don't hit the delete button because then it will delete that column. So after I do that, I hit clear and hit enter. My whole row's gone. Another way to do though is hit the stat button. And you see how number 4 it says clear list. You could go clear list and then hit L1, which is right above number 1. And it would do so as well. Either way to do so. Okay. Let's go ahead back into the stat edit. And I'm going to enter those data. So if you guys would like to do this along with me, but I need somebody to shout out the numbers. 16, 10, 12, 4, 11. Oops, hold on. I did a 1. Okay. 8, 12, 11. Ah, that's stupid 11s. Okay. 11 as well. 10, 4, 6, 7, 7, 10, 7, 11 again, 7, 6, 12, 7, 4, 11, 14, 5, and a 5. Okay, so we have 26 numbers. So once again, that means we're not going to have a direct middle, are we? But notice now what I can do. Okay, I'm going to get out of here and go second quit. Watch what I can do. Go back to stat, and I can calculate some 1 var stats. So calculate 1 var stats. Does anybody have an 83 here today? Okay, I just want to see. If you have an 83, it's the same thing. The only thing different is, see, as I hit 1 var stat, I went to this table. If you have an 83, it goes back to the main screen, right? And you need to know, where did you put your list? I put my list in L1. Does that make sense? Anybody have questions there? So therefore, I can just hit enter, and then I'm going to hit calculate. Okay? So this X bar represents the average. So our average shoe size of everybody in here, excluding me because I forgot to put me on there, is an 8.76 or 8.77. That's the average shoe size. Okay? All this other stuff really doesn't mean anything. We're going to come back to S of X and sigma of X. We'll come back to them in just a minute. But if I continue to push down, notice N tells me there was 26 elements or 26 things we put in. The minimum number is 4. Quartile 1, which we're going to talk about in just one moment, is 6. My median is 9. My quartile 3 is 11. And my max is 16. So notice my median popped up for me, right? It was a 9. My X average pulled up. It was the X bar. Did you find your data as well? I'll show you. Thank you. And then the only other thing that we need to do is we need to go through and actually check which one happened the most, right? So if we look through there, I bet it's going to be an 11. I'm going to count them really quick. 1, 2, 3, 4, 5. Only 5. I thought that happened more. 7 happens how many times as well? 1, 2, 3, 4, 5. So in this case, our mode is what? 7 and 11. Hey, 7-Eleven, yeah! My sister got married on 7-Eleven every day for their anniversary, every time for their anniversary. Anyway, I don't believe anything else happens more than that. Do you guys think anything else happens more than that as you're looking through? I don't believe so. Okay, is everybody with me on how we could find mean, median, mode? All things you guys have learned in the past, right? What if all of a sudden Shaq was in our classroom? Okay, and Shaq all pops out his size 28. Okay, what is that called? That's an outlier. That really disturbs our data, doesn't it? Because, I mean, you're 16, you could almost be considered an outlier, but because we had that 14 and other things, you're still pretty close, okay? Faith with his 4, her 4, sorry, Faith. You're the only girl within my class staying here right now. Anyway, you could have been an outlier as well if everybody else was at, because we're all with fellas, and we're all 11s, and all of a sudden you're a 4, she could have been an outlier, couldn't she? Okay, an outlier is somebody that skews your data. Okay, so Shaq right here, if he came in all of a sudden, he would be all skewing our data, wouldn't he? Does that make sense? Any questions on that? Where do you buy your shoes? Yeah, most of the time. Is that what happens for you, big fella back there that's a 14? Online? Or Ross? Ross with those lovely, I love going in to see those lovely size 22s at Ross. I'm like, why do you even sell these, dude? Is there a 22 person around here just hanging out like, look at all the shoe options? You know? Anyway. But my wife, who is a size 11 in females, she has a hard time finding shoes. She has to buy her shoes a lot online. So as a female, she might be considered an outlier because it's harder. So anyway, any questions on how we find mean, median, and mode? With this information, we are also going to draw a box and whisker. Okay, and here's what the box and whisker looks like. You should have a box and whisker where this right here, here's what it looks like. Sorry, I'm going to just draw it. Now, obviously, this can shift and it could look different, but this is what it looks like. Right, a box and whisker. Okay, our data, this is the minimum. This right here, this line right here, represents quartile 1. What's another name for quartile 1? Does anybody know? Nope. It's the median between the minimum and the median. That is correct. But it's also called the 25th percentile. As you guys just, most of you, because you're all juniors, got your ACT back, you had a percentile in there. What does a percentile mean? It's where you fall. Out of 100 people, you beat 25 people. That's what it means. Okay? So for example, even when I took a GRE, which is kind of like grad school ACT, and I got 100% on the math. But I was in the 92nd percentile. That means how many people did I beat? 92. That means 8 of us in 100 got 100. Does that make sense? So sometimes people are like, well, I scored a 92. No, you're in the 92nd percentile. It does mean different, right? When a lot of your AP tests, they put it in terms of percentiles. So they figure out the percentiles and they're like, okay, we want everybody better than the 50th percentile is going to get a passing grade. That's really how they do it, because they can adjust your score depending upon how hard that AP test is every year. Does that make sense? Everybody with me on that? Okay, this middle line is the median, which is, what's another name for the median? The middle, or average. Nope. Not average. It's the 50th percentile. That should make sense because it's the halfway point. You slept at Megan's? God, having sleepovers on school nights? Do you guys sleep in the same room? No. You and your sister. Okay. What? No, what'd you get? You haven't done it? Oh, the one that you just took in April. This one right here, ladies and gentlemen, is quartile 3. What's another name for quartile 3? 75th percentile. And what do you guys think this one is? It's the max. Say what? So, on our data, let's go ahead and do it. Notice our smallest size was a 4, right? So I have 5, 6, 7. Yes, you have to do a number line. 8, 9, 10, 11, 12, 13, 14, 15, 16. For me, doing one digit on this one wasn't very hard, right? But sometimes you might want to skip by 2s or maybe 5s or 10s, just depending on what it is, right? As long as it's a consistent spacing so that we can get a good visual representation, that's all that matters. Everybody there with me? Any questions with me? Okay. Now, let's go back to our calculator, just so we can see it. Got a new one? Okay. So here's what we got. Minimum 4. Can somebody write this down so that when I'm ready to put it on mine? Min 4, quartile 1, 6, median 9, quartile 3, 11, and max 16. Okay. So let's go and go back to here. My min was at 4, I believe. Is that a correct statement? Quartile 1 was 6. Median was 9. 11. 16. Okay, here's my box. Here's my whiskers. And this can tell a lot of information for us. By looking at a box of whisker, we can look at this. Because notice, ladies and gentlemen, right here, this is only 2 numbers in between my median and quartile 3. I actually just got to put that. It's okay. Thank you. Oh, you're awesome. So there's only 2 numbers between my median and quartile 3. That means 25% of my data is within 2 numbers. So that's very skewed and just very much, there's a lot of our data right there, huh? Notice, look at the numbers between quartile 3 and the max. It's very large. So what does that tell us? There's not a lot. There's only 25% of our data is between an 11 and a 16. So it's so ranged out, that means there could be a lot of here and there. Does that make sense? Okay. Sue, who the heck's Sue? Oh, that's Ryan. I love Ryan. Anyway, and then we have quartile 2, I mean, between quartile 1 and 2, right? Right here. That right there is 25% as well. Notice still a lot of our data. But also, this one over here shows, hey, there's a lot of data between 6 and 4 as well. And that kind of helped us. If we just did your guys' class, you would have been an outlier like we talked about, but because the other ladies were here with you, it helped kind of put it in that it wasn't so much an outlier anymore. Right? We can learn stuff just from a box and whisker just as much. Any questions there? Okay. Continuing on. Okay, now the other information is percentiles. Okay, percentiles. Now, this is something that I've tried to learn to do a lot better than what I've been taught. Okay, if I want to find that 25th percentile, how did they do it? They did the median between the min and the median, didn't they? Okay, but what about the 20th percentile? How do they find that data? Well, that's where it can be off just very close, okay? And this is what I was taught to do, and I don't know if it's the best way to do it, but it seems to work, okay? Is, let's say, how many numbers did we have? 26. There was 26 data points. Okay, and if I'm looking for the 20th percentile, I'm going to times that number by what? 0.2, because 20th percent. So what is that? That's 5.2. Okay, 5.2. Is everybody with me on that? So I'm going to go back to my calculator, which I should be able to look at my stats, and I'm going to go down and do sort ascending. What does that mean? Lowest to highest, right? So I'm going to go sort ascending, hit enter, and then I want L1, because that's where I put my data. It says it's done, so now as I look back there, I can see it. As I look at the edit, notice it's all in order now, isn't it? Is everybody with me on that? Okay, so what number did it tell me to go down to? 5.2. Now, what does that mean? Does that mean 5.2 shoe size? No, it means the 5th or 5.2 numbers in. So notice, 4, that's 1. 4, that's 2. 4, that's 3. 5, that's 4. 5, that's 5. 6 is 6. So 5.2 is between 5 and 6, right? Does that make sense? Now, a percentile means how much did you beat, right? So therefore, 5.2 numbers in, how many people did I beat? Well, I would say that it's 6 is my 20th percentile. Does that make sense? Okay. Yep, I would go up because you're beating that many people, so you want to guarantee it. So if I picked 5, right? The next that's one saying, hey, this score beat 20% of the people. Now, if you look at our data over here, 6 was also the 25th percentile, which makes sense because percentiles can include more than even, like it could include the same number because there could be multiples of those. Yeah. Because you have to beat. So now the next one, let's look for the 60th percentile. 60th. So I'll go 26 times 0.6, and I get 15.6, I believe. Is that a correct statement? Okay. So we're going to go back to our calculator, and I'm going to look down. Now notice if you look right here, it says L1, comma 1. So if I keep scrolling down, notice it's changing. So I don't have to really count. I just look for the 15th term and the 16th term. So look at 15 and 16. Oh, this one's nice because 15 and 16 are the same number. So what is it going to be? It's just going to be 10. Does that make sense to everybody? So this would be, notice we said this one was 6 for the 20th percentile, and this one was 10 for the 60th percentile. Does that make sense how we're going to go about and do so? Any questions there? Now, is that as accurate as maybe what a statistician will do? No, I'm not. We're giving you the basic insights, right? If you guys want to take stats and get a little bit deeper, you can be. Okay, yes, no, we all feel good? Okay. Onward. That's basically 8.1. Now we're going to do 8.2. Still, we're going to talk about that data of shoe sizes still. Okay. We're still going to use that data of shoe sizes. Now, how'd you do? Was it? Well, that's good. We just got done with 8.1, so. Okay. Yes. Oh my, is it a donut? Yes! Oh, nuts and crackers. But I got a Nutri-Grain bar from Nene. Strawberry. Come on, Nene. Okay. Now, the next thing we're going to talk about is standard deviation. Standard deviation. And that has to do with our mean. Okay? Now, a normal standard deviation, like when you guys asked to be graded on a curve, how many of you guys, we talked about this a little bit, right? Or did we not? No, I never. Because if you ever ask to be graded on a curve, that's bad. I'll show you right now. Depends on what curve you're asking. This is called the normal curve. And technically, when you ask to be graded on a curve, it should be off the normal curve. No. I'm showing you right now. Let's learn. I wonder if I'm getting too deep on this. Is this not what I'm doing? Nope. That's later. That's in tomorrow's lesson or next time's lesson. We can talk about standard deviation, but what standard deviation is actually the distance away from the average. And then they go ahead and square those numbers, okay, and then divide it by the number of terms. That's really what it is. You could do this by hand if you wanted to. I would highly suggest let your calculator do it, right? Okay, but what it is, on a normal curve, there's roughly, that's considered, this area in between here is considered one standard deviation. You go to your average, okay, or your mean, right? I wonder why they still call it average. You guys ever wonder about that? Yeah, maybe you shouldn't. Mean, median, mode, standard measures of central tendency. Okay, so what that means is each of these, I didn't even hear what you said. Each of these are equidistant away from the average, which is called the standard deviation. Now, if I do it again, that right there, so I'm going to now fill that out in yellow. So that in between there is 2 standard deviations. Now notice it looks like 4 quadrants of it, right? But it's 2 standard deviations to the left, 2 standard deviations to the right, but both of those are incorporated in a standard deviation. Is everybody there with me and understand? Most data that I have found, and we'll learn about this later, all your data is covered by 3 standard deviations most of the time. Out of all my information that I've ever used, I have only went outside of 3 standard deviations once. And I'll explain that reasoning later when we go over this. But notice this would be considered 3 standard deviations. Once again, this is 2 standard deviations. Excuse me, that was bad. 2 standard deviations, and this is 1 standard deviation. Is everybody there with me? And what happens is on a standard, if you ever want to be graded on a curve, that means half of you guys would pass and half of you guys would fail. You take the average and you go out certain standard deviations. A professor did that on his test one time. It wasn't my class, but he's like, you guys want to be graded on a curve? And everybody said yes. And so he made them sign. Half of the kids failed. So don't, I mean, clarify what's the curve. I'm just saying, there's lots of different names for curves. But if you really are going to curve it, that's technically where the curve comes from. We've all been taught to just get rid of some scores and then make it at, like, the highest score is the 100%, right? But does that make sense? You always screw people over and they piss you off. Then they all get mad at you. You're like, what the hell, Trevor? And then they're going to lynch you later. Get you in the corner. Okay. Well, once again, we can find this information on our calculator. Okay, so going back to the shoe size. Now, I always get stuck on this one because I don't do it well enough, so we're going to use Google for a minute because I want to make sure. Variance. Variance. Fact of being different. Okay. Thanks. That was a great dictionary. Okay. Now, in probability and theory of statistics, variance is the expectation of the squared deviation of random. Oh, that's what it is. Okay. I have no idea how they use variance because I'm not very good at statistics. We don't speak a lot and I'm not in depth at it. Not square root. So we're going to come back to our data. Let's go back here. So we have standard deviation and we have variance. Just be patient, brother. So here we go. Standard deviation. So where's that data? So we're going to go back to our information right here. So I think it was, remember, stat, calculate one var stat. As we look down, okay, these S of x and sigma of x are our standard deviations. Now, 1 talks about sample size, and 2 means the population. Okay, a sample means we're talking about average shoe size, right? Did we not take a sample of the whole world by just using Mr. Roberts' people in his classroom? That's not the whole population of everybody in this world's average shoe size, right? Does that make sense? So the S of x is representing the sample. That's what we're going to be using, is the S of x. Okay, sigma of x, notice they're very similar, right? They're close to each other, would you agree? That's using the population of everybody. So if in the world, our standard deviation would be only 3.2 points away from our average. So let's go ahead and figure out our data, okay? Let's go ahead, what was our average? 8.77, that's what we're gonna say is 8.77, okay? So we're here, our average is 8.77. Now, we're gonna use our standard deviation. Did anybody write that down, the S of x number? 3.28, all right. Now, our variance is just our standard deviation squared. I really don't know what that's used for, though. I'll be honest, I'm not sure. Okay? But it might ask you. Okay? Now, what they do is sometimes they ask us to find the values of the distance of each standard deviation. So how I would do that is like such. I go ahead and do my average, 8.77. And then I go out one standard deviation. One standard deviation, remember, is going out both directions, correct? So I'm going to add 3.28 and I'm going to subtract 3.28. So 8.77 plus 3.28 is 12.05. And if I subtract that, I get 5.2849. Thank you. Okay, so shoe sizes from 5.5, basically 5.5 to 12. You're within one standard deviation of the mean. And that means, I'll tell you later, but I can tell you now, that means 68% of our data is between a 5.5 and a 12. Okay, now I'm going to go out 2 standard deviations. When I go out 2 standard deviations, right here I get a 15.33. And over here I get a 2.21. Now on the lower side, on the low side, I've covered all of our data, haven't I? But we got Mr. Gibby over here, that is big A foot. We haven't got to him yet, have we? So far, our information is still, like sometimes I've seen it that some of your information is within 2 standard deviations. We're close, but we're not there, right? Because what's our highest number? 16. Did we get to a 16? No, so let's go out one more standard deviation. So this would be 18.61. And this would be a negative number. Negative 1.07. Okay. Notice it took 3 standard deviations to cover our data. Like I've said, I've only seen one time when I've done real information with people that I've had to do more than 3. And it can be possible. The most you'll ever see is 4. You won't see anything more than 4. And that's a rarity. Most of the time, your answer is going to be 3. He would be an outlier, but notice what would happen is the average would be skewed, right? But the standard deviation, because of his, would skew it even more, so it'd be really large. So most of their stuff is within 1 standard deviation. Like all the kids would be probably within 1 standard deviation of each other, but then it would take 2 standard deviations more to get to parity. And that's what would most likely happen. Yes, you can. Does that make sense, Trev? What that does is just that skew hurts our standard deviation. Okay, now yes. I don't know what happened. I can't remember how I got that, but 4 standard deviations. It was crazy. And I went there and I'm like, holy moly. When I did it, I was like, I can't believe this is happening because I've never seen it. And you'll see when I teach next time's lesson why it's so remarkable that it happened. I just don't want to get into it now. Okay, now let's talk about some things. What if I shift all of, let's say, because you guys have all seen shoe sizes. In your shoe, it'll say the UK. It'll say different places, right? Let's say that there is a scale, like for example, let's say here in the US, if you have a 12, we just add 30, and that's your Europe size. Does that make sense? Because they're like 40s or something like that, aren't they? So what if I move every data point 30 to the right? What would that affect? Would that affect our mean? Yeah, what would it do? It would just shift our mean where? 30 to the right. Would it affect our standard deviation? It would not affect it at all because they're still the same distance away from the mean. Remember, standard deviation is a distance away from the mean, basically. So therefore, it really doesn't switch that distance, right? Because they're all being shifted. Does that make sense? Okay. So that would affect our mean, but not our standard deviation. Technically, I'll put it up here on the formula because I don't use it enough, so I don't know it, but we can put it up here. Standard deviation. Now, before I do it, I'm going to show you what I believe it is, just so I can prove that I somewhat know what I'm doing here. Okay? So it's the average minus your data point. Now you're going to do that for everybody. I think you square them. So how many? We'd have 26 data points, right? So we do that 26 times. We'd add them, and then I think you divide by 26. I might be wrong, but all of them. Does that make sense what you'd do? Now let's see, going by Google, because like I said, not something I use every day. So this says, yep, there it is. And the square root. I missed it a little bit. I forgot the square root. So what this is that E represents, you guys remember sigma means the sum. So it's the sum of all values, x minus that. It's x minus the average. I was mixed on that. So you'd take x minus your average, square it, divide it by the number of terms there are, and take the square root. If you like to do that, you'll never have to do that by hand. I'm never going to ask you to do that by hand. I have a machine that's going to just plop it out for me. N, the number of terms. So let's go back right. I just wanted to show you I was semi-close, knowing that I knew somewhat. Right? Only thing I missed is this, and then it's actually your data point minus x bar. Which in general, it doesn't matter. It's the same thing because you're squaring it. Say what, bud? X bar, you don't know what it means? Good. D means your data point. So her size 4. What's 4 minus 8.77? And then we go to his shoe size and his shoe size and go from the average and figure them all out. And then you add them all together, divide it by 26, take the square root. But like I said, never going to use it. So onward and upward. Let me make sure that's everything because I think it is. All right, guys, that's it. So that's at least the statistics portion of what we did. Okay. What I would like now is Jared Gibby to hand me my book over there, underneath there. See it? No, not the Bible, not the blue Bible. We're going to do some of that polar to rectangular coordinates and so forth. The stuff that we didn't get to finish last time. Okay? Everybody with me? Hippie-yi-yi-yay. Ay-yi-yay. Hippie, 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 hey. Nope. Same video. For those that are missing, they're just everything they missed. So we're going to go back to 10.7, continued. Okay. We're going to go ahead and write equations. Okay. So let's take a rectangular equation. Let's take a rectangular equation and move it to polar. Okay, rectangular to polar. What do we know y is? Y is r sine of theta. What is, okay, what is x squared? R cosine theta squared. Because it's x squared, right? Because we know x is r cosine theta, y is r sine of theta. So a lot of times we just substitute. What else do we know, by the way? X squared plus y squared is r squared, right? So here we have r squared cosine of theta equals r sine of theta. I'm going to divide everything over to the right side. Nope, I'm not. I'm going to divide these guys over. What am I losing when I do that? What do I become? So 1 over r. Sine, well, I guess sine's still up here, huh? Hi, guys. How did it go? And how did it go? Did you have to think? I was told you didn't have to either. Whoa. So, in this case, I still want to solve for r. Usually, when you're putting them into polar, you want to solve for r. So I have sine of theta equals r cosine squared of theta. Then I'm going to just divide that cosine over again. I guess I went a little bit of a long route. Like I said, I went a little bit of a long route. Notice what's this? Tangent. What's this? That was a long drink. You're like 5 steps away and you're like, screw that, I gotta go back. How'd it go? Good. Okay, so there it would be. R equals tangent of theta, secant of theta. Okay. Now we're going to go from a polar equation into a rectangular. So let's say R equals secant of theta. What are we going to do? Are you drawing on my desk? Yeah. Oh, the name that I wrote on there. Thank you. Thanks, Mr. Rude. Okay, so once again, I know that this is R equals 1 over cosine. You guys agree? Okay, I'm going to times the cosine up. And what do we know R cosine of theta is? X, so X equals 1. It's just a line, like that. Where here's our line, that's 1. Okay? What if they told us just our radius is 2? So a radius of 2, what does that graph look like? Just a circle, right? Because it's all points on radius 2. By the way, that should come out to be x squared plus y squared is 4, right? Because our center's at 0, 0 with a radius of 2. But let me show you how you can show work to do so. I'm going to put r to both, not r to both, square both sides. That's what I'm going to do. R squared equals 4. But what is r squared? We've already learned that too. And there it is. I would highly know how to do this one. Double, double, wink, wink, hint, hint. Not that that's hard. Now here's another one. What if I just told you theta is 5 pi thirds? That means it doesn't matter your radius, you're always going to be on what? 5 pi thirds, right? What if your radius was negative? It'd be going where? Not pi thirds. 2 pi thirds. So this is just a line, right? Because here's 5 pi thirds, this bottom one, correct? But then I'd push through, so it'd be up at right up front right here, bud. Okay? Does that make sense? So now I need to figure out this equation of that line, don't I? Because that's the equation of a line. Because I'll be anywhere on this. If my radiuses are negative, I'm up here. But if my radiuses are positive, I'll be down here, correct? So, well, what do we know about this? Well, if our angle is pi thirds, I know a certain point on this, don't I? What's that certain point? 1/2. And then down Ladies and gentlemen, am I going through the center 0, 0? So that's my y-intercept. What's my slope? Down negative root 3 over 2 over a half. That's my slope, right? So therefore, that's just negative root 3x. The equation of theta equals 5 pi thirds is just the equation negative root 3x. I'll always be on root 3x, negative root 3. I guess a little bit, yeah. Okay. I hope. Because what if my radius, because right now it's just telling me my theta is always 5 pi thirds. So what if my radiuses are negatives? Wouldn't that push me up into quadrant 2? So therefore I need to understand it's this whole equation of this line. So that's because I don't know if my radiuses are positive or negative. So if they are positive, I'd stay in quadrant 4. But if they become negative, I'd have to push through and go up into quadrant 2. So it's anywhere on that line. Okay. Any questions? All right. So I'll hand out a packet for the first part, but I'm going to add some questions on for you guys, okay? So that you guys can do. So back on 10-7. This is going to go on the same homework that you have. Hence why I'm not going to ask you to turn it in. 10-7. So we went all the way to 31, right? So I'm going to ask you to do 33, 37, 41, 49, 61, 65, 67. So I'm going to add those 8 problems to it. Okay. 7 it is. All right. And then your other homework's going to be off the packet that I'm going to hand you out right now. You're going to do 8, 1, and 8. Okay.